To find the gradient of a line on the Cartesian plane is quite easy. We know that we look at how far up we've gone divided by how many units forward. For example, if I was to have a line here like this one, I can see that I've gone 2 units up and 3 units forward. So it's going to be 2 divided by 3. Okay. Also, you might think of it like if I knew this point and if I know that point, what I look at is the difference in the y values between the 2 points over the difference in the x values between the 2 points. Okay, and you might remember that this is how it's written. So we say y1 take away y0 over x1 take away x0. Okay, and this gives us the gradient. Now, when we look at a curve, it's not as easy as that. So if I wanted to find the gradient at this point, it's very difficult. Also, if I wanted to find the gradient between 2 points, I have to think of it like a line. Okay, so I'm just going to draw that and show you what I mean by that. So if I want to find the gradient at this point, let's say, I can see that the gradient of the curve is always changing. And for this curve, the gradient is always increasing here. So around here, it's just increasing all the time. So how do I go about finding the gradient at this point? So for that, we use calculus. And what we're going to do is we're going to differentiate from first principles. So I'm going to say this is a general point. So I'm going to say this is a value x. So some value of x. And I'm going to think about another point here that's some distance away. So another point there, and I can say this is another x value. But what I'm going to say is this is some distance away from my x. So x plus a certain value here. I'll say x plus h. So it's going to be x plus h. So this distance here is h. Let's show that. So between here we have h. And let's think about what's going to happen. So between these 2 points, I can draw a line and I can think of having a gradient there. So the line may look like this. And you can see that this line is slightly above my curve, which sort of curves at the bottom here. Now, if I was to bring this point here and reduce the value of h, so if this point comes closer and closer this way, what's going to end up happening is this red line that I've drawn is going to come closer and closer to the curve. And when that happens, okay, I can see that when I get really close, this red line will end up looking like a tangent. So it will end up looking like a tangent at the point, at the first point that I had. Okay, so if I bring this blue point closer and closer, this red line will be closer and closer, being closer and closer to being like the green line here. So the tangent here will be defined as having the same gradient as this point here, because the tangent here is touching at this point here. That's the common point there. So if that's the idea, let's start thinking about what the y values will be. Okay, so let's say this graph here, the graph that I've drawn here is y equals f of x. Okay, so some function of x. So when I input x, I get f of x. So this value here is going to be f of x. And that value, okay, so that value is, when I input x plus h into my function, it's going to be f of x plus h. Then I think about, okay, so if I now use this definition of gradient and think about making this h value as small as possible, let's see what we get. So if I say I've got a triangle here, so that's what I'm going to draw just to make it clear. So okay, this value here is going to be f of x plus h take away f of x, and on this side I'm going to have x plus h take away x, which obviously simplifies to h. So if I take this formula, difference in y over difference in x, this is what I get. So f of x plus h, take away f of x, over x plus h, take away x, and we said that one simplifies, so let's rewrite that. F of x plus h, take away f of x, over h. Okay, so this is like a general formula for the gradient between 2 points on my curve. Now, what I can do is I can think about reducing the value of h, and this is when we take limits. So we're going to say that we're going to take the limit as h tends to 0. Now, to evaluate limits, for example, this one where we have a 0, we don't just try and put the 0 here and try and solve it, because that won't work. So we have to try and think about a way to simplify this so that h is not at the bottom anymore. So that's what we're going to do. So when we have a function, we can apply this formula and think about what the gradient might be. So for example, if I was to have the function f of x is equal to x squared. Let's look at this one. So f of x is x squared. F of x plus h would be x squared plus 2hx plus h squared. Okay, so I've got this bit here, and I've got the f of x as x squared here, so I'll just replace them now. So I'm going to have limit as h tends to 0, and I'm going to replace the f of x plus h with this bit. So I'm going to have x squared plus 2hx plus h squared, and I'm going to replace the f of x with x squared, and I need to take that away. So take away x squared over h. Now I can see that the x squared and the take away x squared, they sort of cancel each other out, and then I'll be left with a smaller fraction. So limit as h tends to 0, this will simplify to 2hx plus h squared over h. Now what I can see is that I can factorize the h here, and then I can cancel down the fraction. So that's what I'm going to do next. So I can have limit as h tends to 0. I will have h times 2x plus h over h. Now here I can see that this h will cancel with that h. So let's carry on. We're going to have limit h tends to 0. These two will cancel. I'll be left with a 1 here. So that will be the same as having just 2x plus h here. Now that we don't have to divide by 0 like we had to here, so because we had to divide by 0 here, we can't evaluate this limit. But now we've seen that we've put some value, we've thought about a function, and we've put some values for f of x plus h and f of x, and we see that it simplifies to 2x plus h. Now if we think about the limit, so if h was to come really close to 0, almost 0 itself, then 2x plus h must be coming very, very close to 2x. Or we can say that as h tends to 0, this limit will equal to 2x. So what we've found here is a function for the gradient. So we started with the function f of x is x squared, and we've got another function 2x. So this function is denoted like this. So f dash of x is 2x. Now this function, what it does for me is for any point on this graph x squared, I can find the gradient by using the same x value here. So 2 times the same x value will give me the gradient. Here are some questions for you to practice. So what you have to do is differentiate from first principles to find the gradient function. So differentiating from first principles is what I did above with x squared. Okay, so differentiate from first principle to find the gradient function of these functions here.